Hey folks, welcome to another advent of code in F#. We're day 8. Puzzle has just unlocked, had to take out the trash, so I'm running a tiny bit late. But let's take a look at what we have in store for you today. Day 8, Treetop Treehouse. The expedition comes across a peculiar patch of tall trees all planted carefully in the grid. The elves explained in the previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a tree house. Any location is a good location for a tree house. I am a regular watcher of Treehouse Masters. First determine whether there is enough tree cover here to keep a tree house hidden. To do this you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. Okay, elves have already launched a quadcopter to generate a map with the height of each tree. Okay, so every number is the height of a tree over there. Cool. Every tree is a single digit, whose value is its height, where 0 is the shortest and 9 is the tallest. Tree is visible if all of the other trees between it and an edge of the grid are shorter than it. Makes sense. Same row or column. Okay, makes sense. And we're taking a look at every tree. Visibility from outside the grid. Cool. Everything on the edge of the grid is visible. Makes sense. Okay, and we're looking for the least visible tree to hide our tree house in. That's cool. Let me quickly check something here. Okay, there we go. Okay. The top left 5 is visible from left and top, yes. And from the right, no, because there's a 5 blocking it. And from the bottom, no, because there's 2 5s blocking it. The top middle 5 is visible from the top and right. Yeah, okay, I'm starting to get an idea here. So we have every tree on the edge. 1, 2, 3, 4, 5, 10. And 6 is 16, sure. How many trees are visible from outside the grid? Okay, that makes sense. Let me grab my input quickly. Ooh, that's a big grid. What are we talking here? 100 by 100? 99 by 99? 99 by 100, that's an interesting dimension. Okay, that's our input. Let's grab the example as well. Where's my, okay, there we go. Okay. That's the hardest part of the day, getting my input copy pasted. There we go. And fighting with auto formatter, of course. So how let's see how we'll fly, or how we'll tackle this problem. We need to look at every tree, yeah, and then we need to go in the 4 cardinal directions and see whether or not it's the biggest tree. And if one of those directions says, yeah, you're the biggest one of the lot, it's visible from outside. And we can just assume the outer ones. Yeah, it won't be that much work or that much calculation work to figure it out for the outside borders, but yeah, let's do it as the example says, and just assume every border on the grid is visible without even taking a look at it. Okay, time for coffee. Bonus points if anyone can guess this super obscure reference. Let me quickly put it into focus. To the difference engine, and there's 2 people running like superheroes. Okay, let's get cracking. I don't think we need to parse a whole lot. We just need like numeric values in the grid. So, and we need to easily be able to grab stuff in the column and in the row. So I'm thinking a 2D matrix that will be perfect for today. There is a module or data type called array2D. And that allows for some easy grabbing rows and columns and sub rows and sub columns. So I'm thinking I'm gonna try working with array2d today. So let's parse. Is that how I do a for comprehension? For in? I've been writing C# and F# intermingled. Yeah, I think so. Is this grabbing? No? What's I cannot write a basic I cannot write a basic for loop anymore. So that's definitely one line. Why can't I? Do I need to do this? No, I don't need to do this. Or do? Yeah, it's those keywords that always trip me up. Okay, so now we're iterating over every we're iterating over every line. I'm thinking we kind of need to keep. Can I go easily from a 2D or from a string to an array2d? Let's see what this module offers us. That's an empty matrix given 2 dimensions. That's an empty given with some zeros in it. No, there's also a constructor function called array2d. What does that take? A sequence of rows. That's better. Can we not do this? Oh, why have I been writing for comprehensions all this time? This just works. Okay. That's great. We just need integers instead of characters. Yeah. Is there a map function? And 30373, nope. Those are characters, not strings, so that's not working as the way we expect it to. That's maybe working the way we expect it to. Yeah, we have our parsed grid. There we go. What's next? Figuring out how I take other trees in the cardinal directions? No, maybe skipping or counting the number of visible by default trees. Those are on the edge. So that's, you can do lengthy things. There's lengthy things in this array2d module. Let's take a look again. So I can say grid array2d length 1 and 2. So that's the number of whatevers. The other one is the number of whatevers. Let's see if our input is indeed 99 by 100, which would throw us off. Oh, that's, oh no, it's 99 by 99. Okay, cool. It's a square. Not that it really matters, but it's a square. Okay, then we just need the 1 dimension. And we can figure everything out from that. So we need twice the dimension and twice the dimension minus 2. And probably that's simpler, but there's some simplification possible here, but so it's 4 times the dimension minus 4. Right. I think that's even correct for the bigger. So we take 4 times the length of a row or column, but then we counted the corners double. Yeah, I convinced myself. That's the number of a tree on an edge. Those are by default okay, and now we just need to take a look at all the other ones. So how do we iterate over the other ones? How do you iterate over array 2D? No, we don't need to iterate over array 2D. It's... There's Dragon Ball Z in my ears, that's funny. Music is by the Elozai. There's a link in the show notes. It's a fun video game and television music. Or it's original music, but they use a lot of video game inspiration. Anyway, we were iterating over the inner trees. Dimension is what we need, right? So if the dimension is 5, we have 0, 1, 2, 3, 4. So we need to go from 1 to 0, 1, 2, 3. That's minus 2. So these are all the indices we're interested in. Yep. Yeah, I'm thinking, could we do it with a array2d.map? Yes, we can, but then we need to filter out the outer edges or do something special. So let's keep it like this. These should be the relevant coordinates, and now we can grab. Yeah, now we can grab the trees adjacent or not adjacent in the cardinal directions of every coordinate. Let's quickly put that in a variable, the inner coordinates. There we go. How do we grab everything on the row to the left and to the right of this, of one of these indices? Let's see. What's the middle one? 2, 2, probably. What was the syntax again? Was it something like this? Yeah, okay. So you can take, what is this, the entire second row? Yeah, and you can say take the entire second row, that's what we need. Or the entire nth row, where n is 1 right now. And now, for example, if we take the center one, I think we can say from 2 to whatever, 3, and then you get everything to the right of this 5. I was thinking. So yeah, I think we can make it a one-liner to get every sub vector we need to take a look at. I'm just gonna type it out. So I'm going to grab 0, 1, 2, 0, 1, 2, this 3. So at 2, 2 we should have this 3, yeah. Or probably. And now let's take everything to the left. So everything to the left is the same row, but I'm gonna extract row column, so we'll have an easier time to put this in a function in a second. So this is the element at the location. This is the element to the, everything to the left of it. Or we might be off by 1 here, but let's take a look. So 5, 3. Yeah, that's almost correct. We need to have 1 less. So it's C minus 1. It's just a 5. That could be. And then to the right we have same row, but we start at whatever, column plus 1. And we end at whatever, dimension minus something. I'm not even thinking right now, I'm just playing with the REPL, seeing what we get out of it. 3, 2, so that's almost correct. That's just 1, 3. We'll print out some examples in a second and make sure that it's correct. So that's left and right. Let's go above and below. What's happening? Okay. Above. How do we find the trees? Oh, we're not doing it correctly. We need to take a look at the... Yeah, we need to take a look at the trees on the edge as well. There we go. For above, we need to take the column, but what do we need to take? Something like this? Oh, no, let's verify that first. So if we have 3, 3, what's above it? A 3 and a 5. That could be correct. And then we need a 5 and a 3 in the other direction. A 5 and a 3. So that's again starting at row +1 up until dimension -1. Probably. Maybe. Yep. And let's put all 4 of those cardinal direction collections into a list. I don't know why. Let's recap that in a second. But I want to print this out for every tree to make sure we're working correctly. Because there's this single 3 here. That doesn't look correct. Or there's elements of 1 and elements of 2. Something is not correct here. Six and 5 wood. Oh, no. How can left be? Okay, I just didn't rerun these lines of code. There we go. Now everything has 2 elements as we expect. I'm just gonna put this in a function. Neighbor is not a correct word. What's the correct word for all the relevant trees in the 4 directions? Trees between it and an edge, I'm gonna keep calling it neighbor. Neighbors for a given grid and a given row column or given coordinate is this thing, and then we can just return the thing. And it needs to know that grid is an array 2D. Sure, we'll help him. Do I need to specify a type? I do. The type array 2D is not defined. Excuse me? Oh, it's a lowercase a. No? Ah, what was the syntax again to declare this? Okay. I'm a bit rusty on the matrix calculations. There we go. I think we can loop over all the relevant trees now, and those are inner coordinates. And map the neighbors over it, given the grid. There we go. Let's take a look at what we have here. And maybe let's keep the tree in there as well, just for debugging purposes. So we map tree to tree and all its neighbors. Let's see here. Let's take the example. So the first one, interesting location would be 1, 1. Let's format this a bit nicer. Can I still parse if I have white space? Yeah, okay. So 1, 1 is the 5, and it has a 2 on one side, a 5 and 2 on the other side, a 0 above, and a 5, 3, 5. Yep, looks correct. Let's take one other. A 2, 2, that's the example we'll take a look at. That's the 3 in the center, so it's 6, 5, yes, 3, 2, yes, 3, 5, yes, and 5, 3. I've convinced myself we're on the right track here. Yep. Maybe we need to have the tree itself. Do we need the tree itself? Yeah, we need to... No, do we need the tree itself? Yeah, the tree itself has to be higher than every other tree in one of the 4 cardinal directions to be visible, right? Higher. I think so. So let's write the last helper function for part 1. Which is basically array indexing. But I like my abstract data types. I like my functions decoupled from the implementation. And while I'm saying that, it's totally not true for our neighbor's function, but hey, it's my code, I can do what I want. It's not having it. Why is it not having it? I need to type it again. Interesting. There we go. So now we should have the 3 and 2, 2. Yeah, so this is not tree actually, this is coordinates. And then we map to the coordinate again, the tree at that coordinate and all its neighbors. Yeah, now we can do something. What do we need? We just need to figure out visibility for every location. Given a tree and its neighbors, let's write a Boolean function that figures out whether or not it's visible. So a tree is visible if for one of the 4, so neighbors, if there exists, yeah, a set of neighbor where they are all smaller. So I'm going to call neighbors NS to make it super clear and super explicit where all the neighbors are smaller than the tree itself. Sure, and it's complaining about lists versus arrays, so let's keep that in the enumerable or in the seek module for sequence. There we go. 1, 2, 3, 4, 5 plus 5 plus 16 is 21. Should be correct. Cool. So number 3 is on edge. We can grab this and put that here. So this should be the 16 again. 5 again, yeah, sorry. So these are the trees on the inside of the grid. These are the ones on the edge, sorry. And we're looking for the sum. There we go. So this works for the example. Should work for our input as well. Should I dump everything into a huge function? I'm commenting code to see where I'm using where where I'm using what. So I'm using dimension a lot in these. And I'm using grid a lot at these. You know what? Let's not even encapsulate it in a function. Let's just run the whole thing. One final check. Yes, that's correct. Now let's do it with input. That's a bigger number. And that's correct. Yay, go us. Let's take a look at part 2 quickly. Quick copy paste so we don't destroy all our hard work for part 1. Is there only one song on this album? Let me quickly take a look. I've heard Vegeta for an hour now. Oh, I'm looping over a single song. I'm sorry for that. Let me put on something else. Part 2. Content with the amount of tree cover available, the elves just need to know the best spots to build their treehouse. They would like to be able to see a lot of trees. Interesting. To measure the viewing distance from a given tree, look up, down, left and right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller. If a tree is right on the edge, at least one of its viewing distances will be 0. We do need to take a look at trees on the edge now. Elves don't care about distant trees taller than those found by the rules above. What? That sentence is hard for me to parse. Elves don't care about distant trees taller than those found by the rules above. Okay. It's just saying that don't care about any other trees. Cool. The proposed treehouse has large eaves to keep it dry. I don't know what an eave is. Let's quickly... Oh, it's the edges of the roof that overhang. Okay, cool. So they wouldn't be able to see higher than the treehouse anyway. Okay, so they can't look up. That's clear. So one thing to note, mental note, we need to take a look at trees on the edge if I read that correctly. So let's take a look. In the example above, consider the middle 5 in the second row. Looking up, its view is not blocked. It can see one tree. Yeah, that makes sense. Looking left, its view is blocked immediately. I can see that. So that means it can see only one tree. Sure. Looking right, it can see 2 of them. Looking down, we see 1, 2 of them. And then we're blocked. I love this description. So we're calculating scenic scores of every tree now. We need to multiply its viewing distance. That's what we just discussed. In each of the 4. Oh, we need to multiply those. That's cool. So we do 1 times 1 times 2 times 2 equals 4. Makes sense. Consider the tree of height 5 in the middle of the 4th row. What are the odds that one of the trees on the edge will be the best scoring tree? It's possible, I guess. So let's take those into account. So we're calculating scenic scores now. We're doing it for every tree now. And we're taking a look at the tree with the highest scenic score. So what needs to change? We need to take a look at every tree, and instead of counting trees, we need to calculate scenic scores. That's doable. Let's first tweak the what trees do we take into account factor. So yeah, inner coordinates we don't need. We need all coordinates. And that is 0 to -1, probably. So let's quickly verify that. Let's work with example, not with input. I don't feel like counting to 100 today, or not while I'm programming at least. Yeah, appears to be correct. So that's all the trees we need to take a look at. We could just as easily iterate over it. That's basically what we're doing here. But okay, and now we just need to calculate scenic score. For that we do still need to do neighbors. Let's quickly verify that the neighbors thing works now that we're taking the trees on the edge into account. So 0, 0 is the number 3, yes, and it has nothing to the left, everything to the right, nothing above, and everything below. That appears to be correct. Cool. I love it when stuff just works by default, with like safe defaults of empty lists, stuff like that. Okay. Now we need to calculate scenic score for every tree, right? So here we have all the neighbors, and now we just need to calculate scenic scores. I'm just gonna put another map in there. We have a tree. Nope, we have a coordinate, a tree, and its neighbors. And let's calculate scenic score given its neighbors and a tree. That's a new function. I'm just gonna keep piping the coordinate and the tree itself, so it's easier to debug when something goes wrong. There we go. Yeah. Why is my formatter keeping this on a single line? It's not the most readable piece of code right now. I'm gonna keep it at that. I'm not gonna mess with it. So this has the coordinates, the trees, and the scenic scores. Let's take a look at scenic score calculation now. So for each of the 4 directions we need to count. Oh no, we need to take the direction into account. Ah. We need to start from the tree, right? And then go up. So they have to be in order. That's not too big of a problem. Are they in order by any chance right now? So if we take a look at 2, 2, that's our favorite example. We have 6, 5. No, they have to be reversed. The things to the left have to be reversed. The right is okay. The things on top have to be reversed, and below is okay. So left and top have to be reversed. I'm just gonna be pretty nasty here and just reverse it over here. Is it a list? It's an array. So that's left and on top. Let's just reverse those. Easy peasy. Super implicit, but it'll work, I'm guessing. So let's try that again. 2, 2 again. Let's take a final quick check, final gut check. We have 3 at there, yeah, 5, 6, 3, 2, yes, and then 5, 3, and then 5, 3. I'm calling it, no, let's do one more. The one in the top right, it's at 0, 4, it's a 3, yes. There's a 7, 3, 0, 3, yes, nothing, nothing, and then 2, 2, 9, 0. That looks correct. Maybe the final one was the most interesting one. Okay, last one. 9, 3, 5, 3 to the left, yes. Yes, nothing to write, cool. 9223. Yeah, that looks to be correct. So now we have our neighbors in the correct order. I think we now have to loop, or can loop over every set of neighbors. And we can take all the smaller ones. And we need to count them. And then we need to multiply these to get a scenic score, right? Nope. There's a lot of zeros in there. What are we doing wrong? Let's try that again. I'm taking big steps the last couple of days and it's never worked for me, so I need to stop doing that. Let's take an interesting example. What's the example they take first in the problem description? The middle 5 in the second row. So that is 0, 1, 2. 0, 2. It's not a 5. Oh, 0, 1. 1, 2, sorry. That's a 5. Should have a 3 above and a 3, 5, 3 below. Yeah, that's the one. So let's grab that example and let's try to calculate the scenic score for this. These are the neighbors. And the tree itself is supposed to be 5, right? And it's okay, so we have a bug in there somewhere. So let me even take one smaller step. These are the neighbors, so let's put that in a variable. And let's have tree in a variable. And now we can play around in the REPL. Zero, 2, 1, 1, is that correct? There's a 0 in there, that's a problem, right? We can't have any of that. Why is there a 0 in there? Oh yeah, this is the problem. If we see a tree that's of equal height, we can see that one tree. Yeah, that might have been the problem. No, that's not the problem. We might have gone a step closer to 2, 1, 3. It's supposed to be 1, 1, 2, 2. So no. What are we doing wrong here? We are very close. Why is it always the ending that trips me up? So let's go over this manually quickly. Looking up, that's this thing. You can see one tree, so yeah, that should be just this one. Looking left, view is blocked immediately. This is left, and that's blocked by this 5, yeah. Looking right, that's this thing, we can see all of them. Yep, looking down, view is blocked at the second tree. So yes, those are the correct numbers. Why are we not getting the correct numbers? So we're mapping each of these arrays in there, and we're taking from those arrays while they are smaller or equal to the 5 we have here. So that should take this, these two, this, and these two, yeah. Why is it, oh my god, why is it taking, why is it saying 3 at the end? Is take while not working the way I think it is? play around with that a bit. Huh? It should stop, so yeah, the take while is a problem. Ah, yeah, of course. Let's just write our... My brain is too fried to figure out. It should stop at the 5, it should not continue, but it should take 5 into account, right? Yeah, so it should take the 3 and the 5, but then stop. What mathematical... What collection operator am I looking for here? My mind is totally blanking. So let's write a quick function ourselves. Will come up. Just the second I wrote this function is when I figure out what a collection of function we need. So if it's an empty list, we don't need to do anything, but otherwise. When the first element is okay. When it's smaller, yeah, that's the problem actually. So when, let's call these T and T's. And when the tree is smaller than my current tree, I take it and I do the recursive thing. Tail recursion is for another day. Let's pattern match on lists, sure. Yeah, tail recursion is for another day. And then we need one more case. If they're equal, then we just stop. Am I doing it correctly? I think I'm confusing tail recursion and... Yeah, we just need to stop, so it's just a single list containing this. Okay, that'll work. I guess that'll work. What are we not matching on? Otherwise it's also an empty list, right? What's the one-line equivalent of this beast? If someone knows, please leave it in the comments. So that's the grab trees thing, and we're gonna need that here. I'm gonna do a lot of list conversions here. No, that's not the problem. Okay, I'm sorry. What is it saying? Maybe read the problem before I try to fix it. Oh yeah, of course. Argument order matters. There we go. So this take while thing was not correct. I'm gonna leave that here just for... No, I'm not. Yeah, I'm gonna leave that here just for a second. Let's see if we can calculate scenic scores correctly now. Oh noes. Why is it failing? Why is it failing? Oh yeah. No, it should not be failing. A list of arrays. This is a list, but it's actually an array, right? Yeah. Good enough? Good enough. 1, 2, 1, 2, and that should be 4. That's at least 1 we have correct. We don't need this visible for part 2. I think we might be up to giving it another shot. So can we map to the neighbors? We still can. Can we map to scenic scores? There's a lot of zeros in there. There's a lot of zeros in there. Is there something? Coordinate tree. Oh, sorry. Do we have any non-zero scores? Yeah, I even see a 4 in there. Yeah, let's see if it's okay now. What do we need again if we have scenic scores? The highest. You have first and second to dive into parts of a tuple. Do we have third? No, okay. So let's just extract score so we can sort by the score. That's 4, that's not correct, right? Ah! Still not done. Okay, let's take a look. Let's print out all the scores. And what's the one we need? 3 of height 5 in the middle of the 4th row. So that's 0, 1, 2, 3 and 0, 1, 2. It should be 3, 2. Should be 3, 2. What does 3, 2 look like? 3, 3, 4, 9, 3, 5, 3 and a 3. Yeah, that's the one. So what's 3, 2 looking like once we calculate scenic scores? Only 4, so that's not correct. Okay, we have another bug to solve. I'm guessing it will be in the grab trees thing. Because of course. So I'm gonna do the same thing I did just a second ago. Mm-hmm. 2, 1, 2, 1. That is not correct, right? That's very not correct. Left should be 2, yes. Right should be 2. I don't think that's correct. Right should be 2. Why is it mapping to 1? My brain is reaching almost time for a break time. I can think clearly. Yeah, that's not correct. Why is grab trees given the right trees? So these are the right ones. Why is it giving me 1 instead of 2? That's the question we're asking here, right? So it's the 4, 9 thing. Why are you returning 1? Trees is not an empty list. Trees 4 should be smaller, so it should return 4. And then tries to do something else again. And 9 is way bigger. It's the same kind of bug, right? 9 is bigger, but we should include. We should include. So yeah, I think the bug is here, right? and we don't recurse, so we just stop here. Will that be better? Two, 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 one. That's better. That's potentially better. So let's get rid of this again. Yeah. Attempt 2356. Let's see where we are now. Yeah, we got an 8. So that's cool. We got an 8. I'm happy. Let's see if it works for our input now. I've seen people solve today in, I think, 8 minutes. I am running at 50 minutes, so I won't be winning any speed contests here today. But we did solve today's Advent of Code puzzle. So I'm a happy camper. I'm not happy with grab trees, so let's take a look at what we're actually doing here before we close the stream for today. What are we actually doing here? Why is this not just a simple take while? No, I need at least a break to think about stuff like this in any reasonable manner. So yeah, I'm just gonna recap, call it a day, and that's it. What's this? It's the bestest tree, right? Bestest tree. The very, very best of all the trees. There we go. So yeah, quick recap. I will be going over part 2 quickly. We used array2d. I think that's the first time this year I had to grab matrices. And we just loop over everything and do stuff. Looking at neighbors is fun because you can slice and dice arrays with these magical indexing. I don't know what the official terms are, but you can do a lot of cool stuff with ranges and asterisks and stuff like that. So definitely take a look at that if you're doing F# work. And this was the hardest part for today for me. Figuring out how we grab the number of trees that are smaller or of equal height and take that last one with it and ignore all the rest. So I'm really looking forward to alternatives to these 1, 2, 3, 4, 5 lines of code. Please send suggestions. And then we just calculate scenic scores as required, and we do a lot of mapping. Maybe the interesting tidbit for me personally is that I pipe it through coordinates and trees. We don't technically need them because we only need the scenic score in the end. But when I'm writing link queries in C# or all these collection functions in F#, I like to thread in the context or the original requests so you can debug or you can log when things go wrong or when you have to take a look at the bigger picture. So this gives you a bit more context when things blow up. And I did not write a single test, or at least I did not persist a single test. We played around in the REPL a whole lot. Again, very fun puzzle. I loved it. That's all I have for today. I hope you have a nice day, and I will see you tomorrow for Advent of Code in F#. Bye-bye.